So here we have a Mistral brand Living Essentials air fryer. Apparently it's dead. Let's plug it in, double check that it is dead. And I don't hear anything going on there at all. Should light up, should be touch function. There's no power switch. Let's break into it. I believe the top just pulls off on these things. He had a crack at it and kind of loosened it for me already. So how that's held in, I'm not sure. Try down that side. Does it slide? Maybe you just got to be a bit rough with it. No, that doesn't work. Oh, well, it does come out, but it's it's held in the middle. What's holding it in the middle? Nothing. It's got to get the right angle. No, it's pretty basic. What do we got here? Mains cable comes in here. ACL, that'll be AC live. Heater in black. We have heater in blue. So our mains comes in brown and red. Brown and red here. Blue and black are the heating element. It's probably triac controlled then, or could be a relay. No signs of anything exploded. We do have a fuse and a little brown package there. Maybe it's that simple. And then we have a flex that goes off to the front panel. So let's pull the board out and check the fuse. I actually thought there was more to them for some reason. Maybe I've seen one somewhere else that had more in it. We have a motor drive. What's the motor running off? We've got red. There we go. On the back side we have what appears to be some transistors, fan, lamp and motor drive. So this thing does have the ability to spin a rotisserie, fan and rotisserie, and the relay is doing the heater element, so it's just cycling a relay on and off. So if you couldn't quite see it before, the fuse is just the little brown package there, through hole type. So a meter and continuity check, and we should listen for a beep because it's easy, or we could just leave it in resistance and listen for nothing and just watch the screen. So our fuse is blowing. Why is our fuse blowing? The motor and fan and light controls are not fused. They just go directly off AC live, and then through the fuse to the small switching regulator there, and we have a capacitor on the output. So there's our baby switching transformer there, little one there. It's only running a very basic, well, there's actually going to be, I think, the main processor on the front panel, because there's nothing on here, it's just power, and then signals coming back to switch on the motors and light. So just a very small power supply, and there's capacitors, two capacitors down in here under the wires. They are rated at, okay, so we've got two 400 volt caps. That must be our primary side then, and then we've got one on the output which is, well, it's got 50 volt printed on it, but there's no capacitance value, but that's got to be our secondary. Oh no, there's another one, a little brown one hiding in there. The 50 volt one is probably running the switching controller IC. Yes, that'll be the supply rail for that. And this one here is our secondary output, which is 10 volt 470 microfarad. So if our input fuse is blown, it could be to do with the bridge rectifier or a short on those capacitors there, maybe because of the main switching IC failure. So let's have a look for shorts in that neck of the woods. So if we go, there's our two 400 volt capacitors on the underside, which check across there, and we do not have a short there, which is good. Just going to go to diode mode, and here's our, looks like a 2 diode rectifier setup. So half of a full wave bridge. We have no short there, no shorts there. In fact, we have nothing both ways. No, there we go. Maybe I just had a bad connection. No, I've got nothing on that one. Got half a volt on that one. I did. What's going on? There's no conformal coating. There's diodes in that direction. So anode in the middle, cathode at this end, and then anode at that end, cathode at that end. Ah, there we go. Half. Yeah, that's all good. Do we have... There's a input capacitor and a filter there. Let's just check that there's nothing weird going on with those. So we've got filter should go straight through one side like that. And we've got 0 ohms there, and that one should come through that side. That's for neutral. Cool. Let's check for any short on our output capacitor. So here's the brown capacitor there. Let's check our resistance on that. We have over 1000 ohms. So no problem on our secondary side. Well, there doesn't seem to be any reason for that fuse to have blown. So sometimes fuses just fail. They get old and succumb to any high temperatures and things like that, and stresses and startup stresses. So let's replace it and see what happens. So our fuse is just here and here, so we'll just get it melted, bend the leg straight, pop it out. Should be able to just wiggle it out one leg at a time. Rock it back and forwards. There we have it. One fuse rated at probably 3.15 amps. Most stuff seems to be. And it is 3.15 amp. Right, what have I got? I don't have any square ones. It's hard to know what's more common, because every time I order one for something I need, everything else turns out to not be the same. I do have a little round one, so that has the same leg spacing and it will still fit the gap. There we go. Since we've got one hole free, we can just heat up the other one, pop it in. That'll hold it while we find some solder. Maybe it'll blow up. Well, it'll only blow another fuse. Oh, still dead. Let's check our fuse. Ah, fuse is good. Something's not happy. Let's see if we have our secondary voltage. Our secondary voltage will appear on that capacitor. Brown one on that edge. So let's gingerly check that. I'm going to prop that up with, I don't really want to get my fingers in there too greatly. So let's check first maybe we should check, where is our, do we even have voltage on the input capacitors? So across, there's our two 400 volt capacitors, so I should have something across there. Do I? 1 volt. That ain't gonna cut it. How come I've only got 1 volt, or I should have a few hundred volts? So live and neutral here. How much AC have we got? If I go from live to neutral, definitely got a connection there, and that's before the fuse. So that's supposedly coming in from what? It's supposed to be a door switch. No, it should turn on regardless of the door switch. Is there any other safety switch on this thing? But according to that, I have 0 volt. And we're going to go this side of the AC in, 1 volt. Something's not right further in the depths of the thing. 4 screws there, and 2 in the front, 2 up the top to get the control panel out. That just lifts up, and then 2 in the front. Hopefully this will come off. Oh, that's feeling a lot looser. So now I just need to, something's holding it at the side there, at the back. No, I have to take the exhaust grill off as well. Yep. Now that will probably pull off, and it does, so we have to route these wires out of everything. And now this should pull off like that. We have a safety door switch that goes up to here, but that's only a low level controller switch. It's not switching mains or anything. There's our rotisserie motor, and here's our brown wires live in, comes down to here. Why do you think they've tied it off in some heat proof tubing and bonded it or linked it to the metalwork there? I bet I know why. I bet I know why indeed. Right here we've got our mains live phase, comes in through whatever that is and out to down the back. I bet that's a thermal fuse. I bet the thermal fuse has popped as well. Having a look, that just runs down the back to our mains plug. Let's have a close-up of that, shall we? Got a screw holding that on. And a zip tie. Let's see if we can slide tubing off and see what's underneath there. Ha! Look at that. One thermal fuse. And to prove a point, our resistance check of our fuse here. Can you see that? Can I just make it fall all over the place? Yep. Right. Our resistance check of our fuse is good. What? I expected that to be bad. Well, that changes everything. And I don't have to put another fuse in it. What's going on here then? Maybe I should have done this check before. So here's phase. So phase is the pin on the left. The New Zealand plug. Phase, neutral. So we're going from phase to our AC in. What's our resistance there? Oh, perfectly connected. Alright. Let's go neutral to our AC neutral. We have megohms, 6 megohms. That's why we're not getting any power. Alright, where does that wire go? We have our red wire goes to, well, that's our element there. Heater. The blue wire is, oh, okay, it says heater on the board, but they've actually swapped the two pins, even though, yeah, they've actually swapped those two, but that's fine. They go together anyway. Heater, AC in. The blue wire, which goes over the back here to another thermal fuse. That's going to be the problem then. Let's stick this first one back on. I don't know about that zip tie though. I don't think I've got any spare zip ties. Maybe if anything, a zip tie is vibration resistant. If it holds the two together, they can't sit there waggling individually and vibrate and snap off perhaps. I don't know. I also just noticed that the lamp is starting to brown on the connector, and the solder joints there are extra special crusty. So we might have to maybe resolder that while we're here, just to give it a bit more life. Get the other fuse out. It's kind of annoying, the plastic case hangs just over where that goes on. Can I get it out? Oh yeah, that's alright, it can stay there. There we go. And of course, if I take a measurement, listening for the beep. Do we have a beep? We have no beep, so we have one blown thermal fuse. Well, they're putting more than one in there. Okay, what's the number on it? Because I do have some. What have we got there? 10 amp 250 volts, 216. Is that 216 degrees? It is. Okay, let's go see what I've got. Well, I've got these AliExpress specials, which are rated 10 amp 260 degrees, so that's fine. What's another couple of degrees? I mean, if this one doesn't blow, if it's that hot, then it's gonna, the other side's gonna be that hot, you know. It's just a small little oven. Let's see if I can get this one out so I don't have to shorten the wires at all. There's a little bit of length there to work with, but if I can, I'll just recrimp on the end of them. See if I can't loosen the crimp. I think what I'll do is I'll cut the fuse off instead of trying to break the original crimp, and I'll just crimp onto the leg of the old fuse there, and that will surely be good enough. Surely. I've got these little crimps here. They've got like 3 prongs to them, and they just kind of fold over from a bit of a, there we go, and just put a leg in each side and fold them over. Let's see how we go. I haven't actually used these very much at all, so it's kind of kind of a bit of practice. Probably the wrong one for it. A leg up each side. I'm just supporting the crimp in the tool, and that's going to come, make sure the leg comes all the way through, and give it a squeeze. Probably fully deformed. Kinda. I'm not sure. I don't think these are designed to take two leg sized pieces in them. I think it's supposed to be a bit of wire and the leg, because it's hasn't really folded around very nicely. We can't have it being loose at all. I mean, for what it's worth, it is tight, but I don't know if I'd trust it long term. Maybe I scratch that idea and just go ahead with putting the wire on the fuse directly. Can I pull it out? I can't pull it out. Surely it's crimped enough. Kind of feels better using the larger part of the crimping tool than the middle size, which I thought it was for that style of crimp, but that's alright. Nah. I think it should be the middle. Oh, it's tight. No turning, no movement. Cool. Alright. We'll chuck our thermal sleeve back over there. And aim to hook that back under the clamp. Maybe before I do, we'll just check the inline resistance of the power lead. Make sure we have a connection from neutral to there. Yay! Okay, well that should work. Unless we have another fault. We'll put the top back on just for safety. That's better. Where's my control panel? What did I do with that? Moment of truth. Now we find out if it was just a coincidental double fuse pop, or if we have other issues. And 3, 2, 1. Ah, bloody hell! Look at that. Now it should fire up, and it should run. We don't need full steam ahead, we just want to see if it works. Oh, that goes low. Mine goes down to not that low. I think it's power again. Yep, fan spinning. I heard the relay click on, which means the element should be getting hot. Actually, I'm going to crank that up so I can feel it coming out. I must say though, it doesn't spin that fast, that fan. My one spins a whole lot faster. Of course, it's going to modulate the temperature by turning the heater off and on accordingly. Starting to feel some warm air coming out now. Ah yeah, she's hot inside. Excellent. The light works. Yep. And of course, assembly in the reverse order. When removing this, it actually clicks into the bottom here, so you've got to sort of get your spudger under the gap and just give it a lift. It's the easiest way of doing it. Yep. One last test before we seal the lid, because it's a nuisance to pull off, and it works. Give it a thumbs up if you like that, and hope it helps you out. Maybe with your one, there's a lot of these that have a different box around them, but it basically operates in a similar fashion. Thanks for watching.